All right. Beautiful evening, everyone. How you doing? Happy Sunday to everyone. Hope you had an amazing moment today. Uh, we don't have much time, so we want to go straight into our class. Good evening, everyone. Yeah, I can see you. I can see you, Precious Oduayo Akande Praise. Good evening, everyone. Atom, Elon Musk. Good evening. How are you guys doing? Chino and Game Hub. Hope you guys are doing well. Isaac, Amuson, Desmond, Daniel. So this is the moment you can try to inform your friends and colleagues that we're starting right now. Of course, I told you guys the importance of these classes, so please make sure you are inviting them at this moment because we'll be starting immediately. All right. Yesterday, we started with test of hypothesis, and just a quick revision right here. I told you guys that this is a very practical aspect in statistics where we have what we call an hypothesis. I define hypothesis as a claim or a premise that we want to test. And I gave several examples yesterday. For instance, I told you that if it was believed that the average weight of people in a class is 25 kg. Now that's the default hypothesis. I told you we have two different hypotheses. We have the H naught, which is the default hypothesis, and the HA or H1, which is the alternative hypothesis. Now, I told you guys that if the default belief was that 25 kg is the average weight of people in a class, that's going to be the null hypothesis, default hypothesis. Now, if we then want to go on to say that maybe somebody said 25 kg cannot be the average weight of people in the class. So the person wants to say probably, I believe people are greater than that weight, are much more weightier than that. In that case, your alternative hypothesis will say that greater than 25 kg. I gave you the example yesterday. It's possible the person said, no, these people are not up to 25 kg. In that case, you'll be saying less than 25 kg. I also went on to say another instance where we just were silent. We did not know if it was less than or greater than. In that case, we said we don't know if it's greater than 25 kg. We just know it's not equal to 25 kg. So these are the different possibilities for your research hypothesis. Now, I used a different name to term the alternative hypothesis. So, of course, you can note that another name for the alternative hypothesis is the research hypothesis. They are the same. So, whichever one you see, it means the same thing. All right. So, yeah, we have the null hypothesis, we have the alternative hypothesis. Now, I also identified to you guys the diagram for each of these different possibilities. And I told you that it's categorized into two, the one-tail test and the two-tail test. Of course, this two right here represents the one-tail test, whereas this is the two-tail test. And I drew the diagram for you, which is, you can see some of it still right here. This is the right-tail test, that's for greater than. The left-tail test, that's for less than. And this is two-tail test. We don't know if it's less than or if it's greater than. We just know it's not equals to. So we are dealing with the both tails in that case. Also, we talked about test statistics. And I told you guys that test statistics is gotten from the sample data, and it used to define your decision. Test statistics is a very vital part of your hypothesis testing. Very, very vital. You need to understand how important this is. And I told you that for this test statistics, we have different test statistics for different testings. Now, we'll be getting into the types of testing very soon. But just so you know, we have a situation where we'll talk about it very soon, where we have the Z-test. We also have the student t-test, the t-test. Now, we'll also be considering the chi-square test. We'll be talking about also one sample mean test. Then we'll also talk about two sample mean tests. Then we'll also talk about proportion test. One sample proportion test and thereabout. So these are some of the testings we'll be talking about in some coming classes. Now, each of these different testings, we have different test statistics. It's more like a formula. Now, the one I wrote right here is that for the Z-test. So I told you test statistics work in such a way. I told you it's gotten from sample data. And as you can see right here, this is X bar, which is the sample mean. This is S, which is the sample standard deviation. This is N, which is the sample size. So you can see it's gotten from sample data. And this mu here is the hypothesized mean. That's what you're always defining on your hypothesis. We'll come into all this later when we start to solve questions on it. I just want you to get your hands around the meaning of all these terminologies. Now, for t-test, we have its own test statistics, which is very similar to that of Z-test. Chi-square has its own test statistic. By the way, in chi-square test, we have two different types of testing. We'll get into that very soon. All right, you'll see how it in short, this is divided into two. So this test, we have two different types: test of independence and the other one. We'll talk about it very soon. Now, we also have the one sample mean test. All these are more like they just have their own test statistics, and they are all very simple to understand. The major thing when we start to deal with all these things, you would, just so you guys can be very aware already, you would have to cram test statistics for each of every one of them. So whichever test you are dealing with, you would be using the appropriate test statistics. Now, I want you guys to know something. These different testings, they're not going to tell you, please test with a Z-test, please test with a t-test, oh, please use a chi-square test. No, nobody's going to tell you that. I think I have told you guys this when we're dealing with probability distribution. Questions will just come very defaultly. They will just write a question. So I'm going to be telling you guys what you will be seeing that will make you to say, I'm using a Z-test, I'm using a t-test. Oh, I look at this question, oh, it's a chi-square test. Oh, this is a test for independence. You know, you're going to be seeing the different characteristics they should have, all right, that will make you to decide to use whichever of them. Now, I also talked about critical region of a test. And I told you guys that critical region, another name for critical region is rejection region. And in all the diagrams I drew, this tail part, which you see I shaded for the three different ones, is what we call the critical region of the test, the rejection region. And I told you guys that if your test statistics falls inside this rejection region, you're going to be rejecting the null hypothesis. I told you guys that we have two different decisions we're going to be making, one of each of them, one of any of them. We're either going to decide to reject the null hypothesis, or we're going to decide to not reject the null hypothesis. Now, how do you know to reject the null hypothesis? Don't forget, whenever I say the null hypothesis, let your mind come to the real definition of null hypothesis, and that's the default hypothesis, the default belief. So if I say we're rejecting the null hypothesis, I'm saying we're rejecting the default belief. That means whatever was the research hypothesis or the alternative hypothesis is what we are going to be accepting. So we will be rejecting the null hypothesis. Sometimes we will not reject the null hypothesis. I told you guys that all this thing has to do with a situation where something existed. I said probably a company says, okay, our bottles weigh 5 grams. Oh, our candy bars weighs 5 grams. Now somebody felt different. Somebody said, I'm not sure what this company are saying is actually the case. He wants to challenge that. Now you're not permitted to just say, because you felt that what the company was saying is not true, then you go on to now establish that immediately. No, you have to subject it to what we call test of hypothesis. So you have an hypothesis now. That's where it comes from. You have an hypothesis. You have a claim that what the company is saying is not perfect. So you would have to run a test. And when you want to run a test, obviously what you want to do is to pick out sample of whatever you are dealing with. So if you're dealing with candy bars, for instance, and let's say the company says all our candy bars weighs 5 grams. Now you are challenging that. You believe that it's less than 5 grams now because you believe that they are economizing something. So you cannot just accuse the company of not being correct. What you have to do is you will now pick out samples. For instance, you want to pick out probably a sample of 20. Now that sample of 20 now, you will pick out, you get the sample mean, you get the sample standard deviation. Of course, the sample size will be 20 in that case. Subject it to a test. Now, whatever your decision finally, all right, whatever your decision finally is what will now decide, okay, I'm going to hold what the company is saying. I'm going to reject what the company is saying. So that's all about test of hypothesis. There was a default belief, all right? Somebody is challenging it, so you want to make a research on that. So you go on to have test of hypothesis. So now, critical region of a test, again, I said is the rejection region. And I also talked about critical value. That was what we were on yesterday that we ended the class. Critical value of a test. All right. So that was good for revision. By the way, I said some other things yesterday, like type 1 error. I also talked about type 2 error. Can anybody write in the comment section what I said about type 1 error? What did I say type 1 error represented? Anybody in the comment section? What is type 1 error? Type 1 error, a very common question, actually in theory. Somebody said reject null, but it's Kinesia atom. That's you. Okay. Anyway, type 1 error is the error you make when you rejected the null hypothesis when it was true. And type 2 error is the error you make when you do not reject the null hypothesis, whereas it was false. All right, now let's move quickly to critical value of a test. Critical value of a test. So I'm going to give you, let me use, this is a two-tailed test. Obviously, you can see that this is a two-tailed test. When you see a diagram like this, know this is a two-tailed test. All right. This is a right tail test, one tail test. This is a one tail test and a right tail version of it. Now, I'm going to give a sample here. Let's say we have 1.96 here, of course, is the critical value. We say critical value is the value of the test statistics, which defines the upper and lower band of a confidence interval, or which defines the threshold of statistical significance in a test. Now, I want to talk quickly about one of the things I wanted to explain in detail was to talk about confidence level and level of significance. This is vital because I've started mentioning confidence interval, and before I talk about confidence interval, I have to talk about level of confidence and level of significance. Very, very vital. All right. So confidence level level of significance. Please pay attention to this. This is the basics of which many of the things you'll be saying will be defined on. In short, you can't talk about any testing without talking about any of one of these things. You cannot talk about test of hypothesis without identifying the confidence level. Once you identify the confidence level, the level of significance will come out. It's one of the two. They work together. So if you have the confidence level, you have the level of significance immediately. If you have the level of significance, you have the confidence level. So let's talk about this quickly. We're going to be representing this as C. We're going to be representing this as alpha. All right. So please pay attention. I really want you guys to wrap your head around this. I don't want you to get too distracted, because if you get too distracted, very soon many of these things will you'll get hooked in the middle of things, and that will not be nice. When we start solving questions, you may have real issues in comprehending what we're saying. So what's confidence level? Now, the meaning of confidence level, as the word implies, when you're about to run a test, you want to say, how confident are you that your decisions were perfect? Now, we have different confidence level, different. It's possible I decide to test my test, wow. Anyway, it's possible for me to decide to test the hypothesis on a 95% confidence level. Sometimes you can run it through a 99% confidence level. Sometimes you run it through a 90% confidence level. All right? But let me tell you guys something. Running a test on a 50% confidence level, it makes no sense, because in these cases, it's more like you're not even confident of your whatever. In short, why should I accept a test on which you tested it on a 50% confidence level? All right. What you know, who's going to believe you? Who's going to believe your test? Who's going to believe what you're saying? If you said, imagine you were done with the testing and you said, with a 50% confidence level, we reject the null hypothesis. Why should I believe you? Why should I believe that your decision to reject the null hypothesis should hold? Because you are testing that at a 50% confidence level. That's quite very low. So most of the time, which is the most common, is 95%. Then we have 99%. 90 is not even very common. 90 is even quite low. But again, all this exists. 99, 95, sometimes it can be 97. Don't get too carried away with these exact values. It could be 97, it could be 96. With anybody, depending on whatever question you are told to answer. If you're told to answer a question and you are told to subject your test to a 96% confidence level, so you have to run it like that. So you can have any of this. Somebody wrote something out that I would use this to correct it. Somebody said, why is something running on a 2% confidence level? Nothing, no question in your notes run on a 2% confidence level. 2% confidence level is never going to exist. What you saw that you did not understand is significance level. Now, you need to understand that if you're running a test on a 95% confidence level, your level of significance will be 5%. That's why I said they both work together. If you're running a test on a 99% confidence level, your level of significance will be what? Can you guess? What will it be? If you're running on 99% confidence level, what's going to be your level of significance? Anybody following? 1%. So you need to understand they work together. So if you're running on 95% confidence level, your level of significance is 5%. If you're running on 99, your level of significance is 1%. If you're running on 90% confidence level, your level of significance will be 10%. Just that way. So of course, I'm sure you are able to establish the correlation between these two. That C is going to be equal to 1 minus alpha. All right. And if you look at it, Or you can say alpha is 1 minus c. Anyhow you want to write it, it works both ways. Alpha equals to 1 minus c. Now, look at the meaning of this. If you had 95% confidence level, that's 0. Of course, you know 95% is 0.95. I'm sure you guys recognize that. So that means alpha here will be equals to 0.05. So simple. So look at what happens here. Sometimes when they're asking you a question, please guys, this is introductory class, so we're going to it's not wrong for us to dwell on the basics using our time, because you guys need to understand these things well. We're not rushing. Everybody should be able to comprehend what we're doing. Now look at what's going on here. I need you to understand that your question will not always say on a 95% confidence level. They may just say, sometimes they will not even say it. They will not even tell you what they are saying. They will just write under the question, take alpha equals to 0.05. That's what they will just, sometimes they just write this. All right. You just see them write alpha equals 0.05. All they are saying here, alpha is level of significance. All they are saying there is that level of significance there is 0.05. Of course, this means that you are running that test on a 95% confidence level. So understand the way these things work. So sometimes you may just see them say that alpha is 0.02. Now guys, if alpha is 0.02, who can tell me what level of confidence we are running this test on? For alpha being 0.02, anybody? Quick, drop it quickly. If alpha is 0.02, what level of confidence are we running this on? Can I get an answer quickly? Fastest finger. Okay. Somebody wrote 0.98. That's correct, but I wanted you to have said it as 95% confidence level. So if we are having our level of significance to be 0.02, that means our confidence level is 98% rather. So 98% is our confidence level in that case. So know how to fix all these things. They are quite very, very simple. So confidence level of significance, they are all telling you the strength of confidence of which you subjected your test to, and your decision bears on that. So if I said I'm running this test at a 99% confidence level, that means already I'm telling you that, see, with a very full assurance, strong assurance, the decision we made is very solid. But if you go on to say I'm running a test on a 50% confidence level, you are free to do that anyway, but of course you have told us already that we should hold your decision very lightly, because it's not being run on a very strong confidence level. All right, so let me give you the definition of this terminology, level of significance, quickly. I'm going to say this because this is very vital, and sometimes it can come out in an objective question, and I don't want you guys to just, of course, I've explained it in a very much in a way that a layman can understand, but let's please talk about this with a much more technical terminology now. Denoted as alpha, it is defined as a fixed probability of wrong elimination of null hypothesis when in fact it is true. Guys, I hope you know that the level of significance is stated to be the probability of type 1 error. Note that, very, very important. The probability of type 1 error is the level of significance. So tomorrow, if they ask you to define level of significance, remember that the probability of type 1 error is level of significance. Note that. Of course, this is introductory class, so all these things are something you should note. Level of significance is the probability, the fixed probability of wrong elimination. Of course, that means rejecting of the null hypothesis when in fact it is true. And you know that, of course, the error you make when you rejected the null hypothesis when it was true is type 1 error. So you can summarize it by saying, by the way, if you are told to define this, please don't say level of significance is stated to be the probability of type 1 error, because you need to explain what type 1 error is if you had to say it that way. All right. So you had to say type 1 error is the error you make when you, so before, don't just say the probability of type 1 error, because that way you are bringing a much bigger terminology. So you need to explain what type 1 error meant. All right. So we can say the significance level of an event is probability that the event could have occurred by chance. Probability that the event could have occurred by chance. If the level is quite low, that is, probability of occurring by chance is quite small, we say that the event is significant. All right. Level of significance means how sure a researcher is that the results found are not accidental. I told you guys that when you say level of significance, it still goes vis-a-vis with confidence level. So if you're saying level of significance is 0.05, that means you are saying you are having a strong confidence, a 95% confidence that what the results you found are not accidental. So level of significance means how sure a researcher is that the results found are not accidental, not by chance. So a level of significance of 0.05, that's alpha being 0.05, means that there is a 95% probability that the results found in a study are the result of a true relationship between groups being compared. So it's not by chance, it's not accidental. It also means that there is a 5% chance that the results were found by chance alone and no true relationship exists between groups. So you see that if we said we're running this on a 95% confidence, that means we are saying 5%. There's a 5% chance. If we said we had 95% confidence, that means we are saying there is a 5% chance that the results were found by chance alone and there was no true relationship between the groups that you compared. So if you said you are running a test on 95% confidence level, that means you are saying there's a 1% chance that the result you found was by chance alone and there was no true relationship between groups. So now, can you now refer that back to what I said, probability of type 1 error? Because if there is a, let's say 95%, there's a 5% chance that the result you found was by chance. That means we are saying, see, I'm only 95% confidence. That means there's a 5% chance that you would have probably rejected the null hypothesis when it was true. Do you understand what I'm saying? There's a 5% chance of you reject. That's why we say it's the probability of type 1 error. That's the 5%. This probability, it's what happens when you are not so, this 95%, you are so sure that, hey, things are perfect. What we are doing here is not accidental. But there's a 5% possibility that the result you found was by chance and there was no true relationship between the groups. And if this 5% chance, considering this 5% chance, that means you would have rejected the null hypothesis when it was true in this 5%. So that's why we said alpha, which is the level of significance, is probability of type 1 error. Probability, this is probability of you committing that error, of you rejecting H naught when it was true. All right. So if you can understand if you can wrap your head around all these things, you are very good, sincerely. So if I said 90% confidence level, that means I'm saying there's a 10% chance that the result you got was accidental, that it wasn't there was no true relationship between the things you compare, the groups you compare, the samples you took. That means you're not there's a 10% chance that was by chance. So I'm sure you guys can really understand what I'm saying. It's a very simple. You need to understand these things well, and then there's nothing you see out there in any question that looks very difficult. So that's that about that. And so we have been able to define many of all these things, and I'm sure you guys can really understand what we've been saying. So guys, Alpha, how do you guys feel? All right, that's good. I love that you feel good. So let's go quickly to I want you guys to quickly write the null and alternative hypothesis in these questions I'll be reading. So you listen up and then you would, yeah, somebody says it's looking simple. It's actually simple. All right, Atom, well done. I see you there. Now, writing the null hypothesis, let's do that quickly. You guys will give me the null and alternative hypothesis of all these things I'm saying. Now, a company has stated that their straw machine, now there's a company that makes straw machine. A company has stated that their straw machine makes straw that are 4 millimeter diameter. So this company now said, come, our straw machine, it makes straw will be 4 millimeter in diameter. That's what this company said, that our straw machine makes straw that are 4 millimeter in diameter. A worker believes that the machine no longer makes straw of this size. Now, a worker now believes that the machine no longer makes straw of this size. Now, he samples 100 straw. He samples 100 straw. Of course, you know, in that case, he samples 100 straw. That means your end there is 100. All right? To perform a hypothesis test with 99% confidence. So you can see what's going on here now. So a company has stated that their straw machine makes straw that are 4 millimeter diameter. That's what the company is saying. The worker believes the machine no longer makes straw of this size and samples 100 straws. So he now takes a sample of 100 straws to perform a hypothesis test with 99% confidence. So guys, I want you guys to state the null hypothesis and tell me the level of significance of this test. So can you state the null hypothesis quickly, guys? State the null and alternative hypothesis, and then also tell me the level of significance of this test. Anybody with an answer? Null hypothesis. What's your null hypothesis? What's your alternative hypothesis? And permit me to also use the word or research hypothesis instead of saying alternative hypothesis. I want you guys to get familiar with this. So what's your null hypothesis here, guys? This is a very vital part of solving questions. You must know how to state your hypothesis. Not every question will give you this. All right, thank you. I can see somebody there. This is how you're going to state your hypothesis. H naught. You're going to say, because they said, now let me quickly address something. Someone will be asking that why are you going to be saying mu? Why do you use mu here all the time? Mu equals to 4 millimeter. I did not hear them say average. Guys, pay attention. Just pay attention. Let me explain why you're having this as mu. You understand that I'm always a big fan of making sure that there is nothing in the topic that you don't understand. It's not magic. Mu here represents population mean. If the company said their straw is 4 millimeter in diameter, that means each of their straw is 4 millimeter in diameter. So if you bring 1,000 straw, what's going to be the population mean for 1,000 straw? It's going to be 4. Since they said everything is 4 millimeter, that means the average. If you said 4 millimeter is everything they produce, that means the average is going to be 4. Because if you do 4 in 10 places divided by 10, it will be 4. 4 in 100 places divided by 100 will be 4. 4 in 1,000 places divided by 1,000 will be 4. So whatever number they are producing, since they told you that the population, each of them is 4 millimeter, that means the population mean, you can see it's population mean we wrote here, will always be 4. All right. Now, the research hypothesis, the alternative hypothesis here, he did not say he's believing that the straw are now greater than 4 millimeter. He did not say he's believing that the straw are less than 4 millimeter. All he said is that I just believe that the straw is not of this size. So it's going to be a two-tailed test. I'm sure you guys understand that. I told you guys that when you have not equals to, it's going to be a two-tailed test. That's the diagram is going to look like this. If this was greater than, it's going to be a one-tailed test. That will be a right-tailed test. If it's less than, it's going to be a left-tailed test. That will be a one-tailed test, obviously, but a left-tailed version if it was less than. So this is your null and research hypothesis, your alternative hypothesis, and your alpha here will be what? 0.01. So this is how sometimes they will write the question for you. They may not, it's not every time it comes in word problem. You'll just write something like this in your exam, in your theory, and they will say test this something. That's how it used to come out. So just note that. Well, let me see how you do with this next question. Let me see how you do with this next question. Doctor believes that the average teenager, obviously, doctor believes that the average teen sleeps on average no longer than, guys, pay attention to this. I'm going to use this to explain something very vital. Doctor believes that the average teen sleeps on average no longer than 10 hours per day. Please take note of everything I'm saying. The doctor believes that on average, that the average teen sleeps on average no longer than 10 hours per day. A researcher believes that teen on average sleep longer. A researcher believes that teen on average sleeps longer. Write H0 and HA. Write H0 and HA. Doctor believes that the average teen sleeps on average no longer than 10 hours per day. A researcher believes that teen on average sleep longer. Write H0 and HA. Okay, I'm looking at some answers. HO mean less than I'm seeing different answers. Okay, I think I seem to be leaning towards what Omojola is the person that has gotten the right one. Akonde Praise has gotten the right one also. Yeah, that's nice. I like that. Let's look at the question together because this is very vital. Look at it. Doctor believes that the average teen. Doctor believes, that means the null hypothesis is going to be on the basis of whatever they say next. That the average teen, on average, of course, sleeps on average no longer than, that means not more than. Now, the meaning of not more than, of course, things that are not more than 10. If this is 10, not more than 10. It can be 10, but not more than 10. It can be 10, but not more than 10. That means you're talking about the mu being less than or equals to 10. Because they said no longer than. It's going to be mu now. We're not going to, it's going to be mu. Somebody asking, it's going to be mu because this population mean. We're talking about the average thing. So it's going to be mu. So it's going to be mu. Just take it that way. It's not complex. That's not very complex to understand. Now, a researcher believes that teen on average sleeps longer. So a researcher believes that teen sleeps longer. Longer now, not exactly 10, but longer. So you can see that the null hypothesis is the one that houses this, whereas the alternative hypothesis houses this. Now, this brings me to something I need to expose you guys to. In almost every situation you'll be dealing with, almost everyone, it's on very rare cases where you you need to understand that the equals to always shows up on the null hypothesis. Note that for you to even know that you're on point, except in a very, I think if I've seen that, probably very rarely. I'm not even so sure it's something I've seen so much, where you see this place not having the equals to. In almost every cases, the null hypothesis is always going to hold equals to. Now, it could be less than or equals to. Sometimes it could be just be equals to. It could be greater than or equals to, but equals to will always be there. The reason for that is because I don't want to go. Don't let me get into that right now. Maybe when we start to solve. But just note it that way. The null hypothesis always handles the equals to in almost every cases. All right. Good. So this is what the null hypothesis and alternative hypothesis. I'm sure many of you guys got this, and if you didn't get it, I'm sure you have learned from it. All right. Good. Let's go to the next question. Let me see how you guys fare with this. The school board claims that at least 60% of students brings a phone to school. The school board claims that at least 60% of students brings a phone to school. A teacher believes this number is too high and randomly samples 25 students to test at a level of significance of 0.02. Write H0 and HA. So the school board claims that at least 60% of students brings a phone to school. A teacher believes this number is too high and randomly samples 25 students to test at a level of significance of 0.02. Write H0 and HA. Can we do that very quickly? Okay, now, I told you guys yesterday that it's not every time your null and alternative hypothesis will be having mu. In this case now, this is a different scenario. You'll be using proportion in this case. So those of you that are writing mu, you are not correct because this is not anything around mean. You can see we're dealing with proportion here. At least 60%, that's proportion, not mu. That's not, that doesn't have anything to do with average. It has to do with proportion. So if you're dealing with P here, so in this case, you'll be having your H0, P, that's the proportion, claims that at least 60% of students, at least 60%, that means the least is 60%, but it can be greater than at least 60%. That was the belief. Now, a teacher believes this number is too high. That means it's not up to. So the teacher now, which is the research hypothesis here, is saying that this proportion should not be up to 60%. So that's how you're going to state your null and alternative hypothesis. So he's saying the belief that the school board believed was this. The teacher is arguing that he doesn't accept this claim. So he is believing that he's not supposed to be up to this. So of course, you cannot hold the teacher's own. You have to subject this to a test. And don't forget, we were told that he randomly samples 25 students. That means in this case, N is equals to 25. And at level of significance of 0.02. That means alpha here is 0.02. So this is so good. I'm sure you guys are really enjoying yourself. This is how simple this is. So that's that about that for writing hypothesis. I'm sure you guys have gained. Very soon now, you'll be getting into questioning where Somebody is talking about maybe not writing 60% here. Of course, if you go on to write 60% here, it's still the same thing. 60% is 0.60. So that's not something that's supposed to give you an issue. If I wrote 60% here, 60% is 60 over 100, obviously, which is 0.60. All right, now let's go to something beautiful, which is, we talked about this already, but let's now go into how to find them. Critical values. Critical values. Now, we're going to be starting, the very first test we'll be dealing with will be Z-test. But I will not yet talk about Z-testing so much today. I want to still, I want to take it one step at a time. So let's talk about critical value. And under Z-test, we'll be, of course, calling it the Z-score. I believe everybody that followed us with the normal distribution is, you guys cannot have any issues on critical value. If you follow through with normal distribution, it's just so simple. The same knowledge you use in normal distribution is what you're going to be using here. So there's no big deal at all. You're going to be very fine. Critical value. Now, I'm sure you know critical value, let's say, and rejection region. You know why this goes together? Because look at this example we have right here. You have this curve, obviously. If this are the critical value for this particular scenario, of course, you know that this shaded part here represents the rejection region. This and this, they are both the rejection region. All right. So that's why when we talk about critical value, we also will talk about rejection region. Now, the meaning of critical value, that's the point that will define where your rejection region commences from. So if we said minus 1.96 is the critical value, that means anything towards the left on this side now, we will deem this falling under inside the rejection region or the critical region. Another way of saying rejection region is the critical region. Same thing goes for 1.96. If we said 1.96 was the critical value now, anything above 1.96, we would say it has fallen inside the rejection region or the critical region. So it's that simple. So the next thing now is, how do we now get these critical values? How do we get them? How do we get them? That's the question I want to answer now. So please, if you know, this is introductory, so please make sure you are very attentive. Now, depending on the kind of test you are dealing with, guys, please pay real attention at this point. Your critical value will be dependent on the type of test you are dealing with, and also your confidence level. Let me draw. Okay, let me draw. I'm going to draw the three charts again. I'm going to start with the right test here. I'm going to go on with the left tail test, and end up right here with the two tail test. Guys, please pay attention. Please pay attention. I know why I'm saying this. Get this once and for all. Of course, you already know what you're going to be dealing with that will make you to say something is a right tail test. I told you guys that already. That means in this case, your research hypothesis, whatever you're dealing with, was greater than. That was why you came to this test, to this scenario. For this one, your research hypothesis will be having less than. So once you wrote your research hypothesis with a less than, know that this is the diagram you are drawing. Now, for this case, your research hypothesis, that's your alternative hypothesis, will be not equals to. This is what defines whatever your diagram will look like here. Now, let me quickly tell you a very vital point that you must never forget. This is where the guys that will know how to solve questions on this topic, this is where it's going to be defined on. If you understand what I want to say next, getting your critical value will be very easy. So pay real attention. This space, of course, this is the rejection region. This is the rejection region here. And this both represent the rejection region. Guys, the area of your rejection region, please listen carefully. The area of your rejection region is always alpha, the level of significance. Note that. So the area of this rejection region is alpha. All right? The area of this rejection region is alpha. So guys, I want to ask a very vital question here. What's the area of this place? Can anybody tell me what's going to be the area of this place and the area of this place? Anybody? I want this to be interactive so that you guys can get the best from it. I told you that the area, look at what I said. I said the area of the rejection region is alpha. That means the area of the rejection region is the level of significance, if you wanted to say it in that way. So guys, what's going to be the area of this place and this place? Anybody? Let me get the answer. People wrote 2 alpha, somebody wrote 2 alpha, somebody wrote alpha square, somebody said 1 minus alpha, somebody said 1 plus alpha. Any other answer? Any other response, please, guys? Give me more responses so that you guys can understand this. I don't want to just be talking. That way you may tend to get out of what I'm saying. 1 minus 2 alpha, alpha to 2 alpha, alpha. Okay, guys, the question I asked was quite very simple. If the area of the rejection region is alpha, that means this is the rejection region. The area here will be alpha over 2, alpha over 2. So simple. So just go on to say alpha over 2 plus alpha over 2. Is it not alpha? Alpha over 2 plus alpha over 2 is alpha. Is it not? So the area, I repeat, of the rejection region, the total area of the rejection region is alpha. That's standing. So when it was just this place as the rejection region, the area is alpha. When it was just this place, the area is alpha. Now, when we're dealing with the rejection region being split into 2, the area is still alpha. But in these cases now, you'll be splitting that alpha into 2 also. So simple. Does it make sense? This is quite beautiful. Note this. I've told you, I said this and note it. The people that are going to be very good at this topic, they would understand what I just said. And it's very simple. Alpha is the area of the rejection region. Now, of course, we've done some quick examples. Your alpha may be 0.05. That means if your alpha is 0.05, that means the area here is 0.05. If this was 0.02, let's say your alpha was 0. That means this space here, the area here is 0.02. The same thing goes for this other one. Now, if alpha was 0.05 and you are dealing with this kind of scenario, that means your alpha, your area here will be 0.0. If alpha was 0.05, this was your alpha that they gave you in your question. All right. If this was your alpha and you're dealing with a question that is a two-tail test and your alpha was 0.05, that means your area for the left-hand side will be 0.025. You divide this by 2, and this area also will be 0.025. That's the way you deal with questions of this sort. All right. Now, I want to throw, of course, if this is the rejection region, then obviously this will be the acceptance region, so to say. Acceptance region, that means this is the rejection. Anything that falls inside this place makes you reject the null hypothesis. If it falls here, you will not reject the null hypothesis, meaning you will be accepting the null hypothesis. Can anybody tell me what's going to be the area of this place? What's going to be the area of this acceptance region, guys? What's going to be the area of the acceptance region? Thank you very much, Adebola. C. The area of the acceptance region will be C. Another way you can see that is that you can take this as 1 minus alpha. And obviously, 1 minus alpha is C. You know that already. If they give you 0.05 as your alpha, of course, you know that your C will be 1 minus 0.05, which will be 0.95. So obviously, your C is 1 minus alpha. So note this very important thing. All right. If your alpha is here, that means this place is your C, or your 1 minus alpha, anyhow you want to see it. This place now, the acceptance region here will still be C. So we can conclude now to say that the area of the acceptance region is C. Very simple and very straightforward. This is key to you understanding questions on this topic. All right, note what I just said. Note it, digest it very well. The area of the rejection region is alpha, which is the level of significance. And the area of the acceptance region is C, which is 1 minus alpha. Now, guys, let's get real right here now, because now we want to start. Let's bring in different scenarios, and you guys will see, you would agree with me how extremely simple this topic will be. Now, if you understood what I just said now, then that means you are done. You are like good to go. There's nothing else that is going to challenge you. I can assure you, when it comes to Z testing. Of course, every other testing has their own peculiarity. We are majorly still dealing with Z test right here. So, but let's go on now. Let's see something. Let's try and do something now. So, guys, they told me that I was working with a confidence level of 95%. And I was dealing with, let me just draw an example. Let me say H naught was mu equals to 4. HA was mu greater than 4. Now, I want to teach you how to get the critical value. For you to get the critical value, there are two important things. Number one, you must know what kind of test you are dealing with. Is it a left tail test, a right tail test, or a two-tail test? So you need your research hypothesis to be able to find your critical value. All right. Number two, you must know either your confidence level or your level of significance, whichever one, you must know. So these two things are very vital. Without these two things, you will have real issues in getting your critical value. Now, with this question we have right here now, I can get my critical value. How? First of all, I want to draw my diagram. I can see this is a right tail test. Right tail test, so I'm dealing with something like this. Good. I can see that my confidence level is 0.95. I told you already that the area of the acceptance region is confidence level. So the area here is what? 0.95. That means the area for this other space will be what? 0.05, which I told you was the area of the rejection region, alpha. Good. So what do you want to do next? Very simple. Go and pick your Z table now. Go and pick your Z table. I believe you guys have your Z table. Then you will go on now to pay attention. When we're dealing with normal division, majorly we were always saying, this is how we used to, when we're dealing with normal division, this is what was happening. This is not a symmetric curve, by the way. Let me try and make it at least a little bit symmetric. So under normal division, we're saying, maybe we said this place is 1.71. Then what you guys were doing was, you went on to look for the values for the probability when you had 1.7 under 0.01. I'm sure you guys recall this. We did all these things. Then you go on to now say this area here was whatever you got. Remember when we were dealing with that? That means we said the area here, because your Z table, which I believe everyone should have by now, brings out probabilities. So when you have 1.71, I told you it reads from left to right. So that means it brought out the area from left to right. When you check your Z table of 1.7 under 0.01, what the answer brought out was the area from here up until that 1.71. So it brought out all this area, all right? Now, you're going to use that same Z table now. You don't know this place now. Let's say we said this place was 0.9405. It's more like reverse engineering. Before, you knew 1.7 under 1, you went on to your table. Can you guys please hold your table right with you? Let me do a much more, because we have to be more practical. So open your table right now. Let's use it. Your Z table, very, very vital right here. Okay, so look at your Z table right now. So let's say we're dealing with 1.7 under 1. 1.7 under 0.01 was 0.9564. 0.9564. So let's run something quickly, guys, with your table. Let's assume I did not know this place was 1.7 under 1.71. What I needed to do was to, in this case now, when you are giving the area, but you don't know the Z score that produced it, this place right here is what we call the Z score. What you have here is what we call the Z score, by the way. That's why you can see we said critical value, and we put in brackets Z score, because in this case now you'll be finding the Z score. Before you were using Z score, you know, Z score, after we did standardization, we got a Z score. Don't forget, we said Z. When you were done standardizing, you will say Z, probability of Z greater than maybe 1.56. Then this was the Z score now. So you were looking, you remember all these questions. So this was the Z score, all right, after you were done standardizing. But now we don't know the Z score, but we know the probability. We want to use the probability to find the Z score. So the way to deal with questions like this is that you will not be checking the Z score now. You'll be checking inside the table. So let's say I had an area of 0.9564 and I wanted to find the corresponding Z score. I will go inside my table. Inside that table, of course, you know how the table is. I believe everybody is aware of that. We have the way the table is arranged. We have Z, we have 0.0, 0.1 up until 3.4. Then we have 0.00, then we have 0.01, we have 0.02, and so on. So for you to find the corresponding Z score for a probability, you know, before when you were finding Z score, when you were looking for probability given the Z score, you were checking here under something, then you said 3.4 under 0.01. You pick the value. That was what you were doing there. Yeah, what you will do is that you will go inside, for this case now, you go inside these probabilities now. You go and look for, let's say you're looking for 0.9564 now. So you will painstakingly have to go through all those values. Of course, you know, they are all arranged properly in such a way that you know where 0.5 is, you know where 0.9 is. So when you don't need to check some, you know, you need to check all the values to know where you're going to. So when I see 0.9564, obviously I don't want to be checking where 0.5 was written. I don't want to be checking where 0.7 was written. I want to go where 0.95 is being written. So if you look at what we have right here, I can see 0.9564 it was from 1.7 under 0.01. I saw it on 1.7 under 0.01. So I can obviously say the Z score there was 1.71. Does it make sense to you guys? That's the way you will find the Z score from probabilities. So if you have a probability, you go inside this section, find the probability and go and look for the z-score that produced that probability. That's where you use the table to find z-scores. Now, I need to tell you guys that there are some scenarios where you will not get the exact value. Okay. Now, can you guys tell me if you can see 0.95? Let's assume we are not dealing with this 1.71 now. So let's focus on the question we were dealing with before, this one. So now we have 0.95 now. Can you guys go and find the z-score that was associated with 0.95 as a probability? Of course, go within the table now. Start looking for 0.95. And let's see, are you able to get exactly 0.95? So it's possible sometimes you see 0.95 exactly. It's possible. Can you guys see, can you see 0.95 inside your probability? 0.95. Exactly 0.9. Anybody, can you see 0.95? Exactly. Now, with what I can see clearly that there is no 0.95. I can see from the table, I can see 0.9545. Is that correct? Sorry, 9495, sorry. I can see 0.9495, all right? And I can see 0.9505. Look at what's going on right here now. Now, in a case where, look at, this is what I can see. Somebody is saying 0.9599. 0.9599 is quite far from 0.95. So 0.9495 and 0.9505, they are the closest to 0.95. There are some cases where maybe, let's say for instance, the next one after 0.95, let's say this was 0.15. Now, if this was the case, that I have 0.9495 and 0.9515, I will automatically pick this one. You know why? This is the closest. You can see this is just 0.0005, close to 0.95, 0.0005, close to 0.95. Now, if this was the case, if this was the second one, I will not pick this one because this is quite still far. This is far. This is 0.0015 away. This is farther. This one is far. If it was 0.9515, I will not pick this one. If this is the only one I will go for. But in this peculiar case now, look at what is happening. This one is 0.0. Look at this one. This one is also 0.0005 away. So this one, this value is 0.0005 near it, before it. This one is 0.0005 after it. So you can see already that these two are the closest and they have the same distance away from 0.95. So obviously it looks more like confusing. Which one do I pick? Do I pick this one? Of course, if you look at the value that produced this, I believe you guys that are looking at it, it was, can anybody tell me the Z-score that produced this value from your table? The Z-score that produced 0.9495. 0.9495 was produced by 1.6. It was 1.6 under 0.04. That was what produced 0.9505. All right. 1.6 under 0.04 produced this. And 1.6 under 0.05 produced this. Now, if these two things, if this was the closest and this one was not equally as close, we will just pick this one and run away with it. All right. We'll just say 1.6 under 0.04 is what we're going to go with. But in the case where they have similar distance, what we have to do is to say, of course, 1.64 plus 1.65 divided by 2. That's what you're going to do. So in the end, you will see that your Z-score will be 1.645. That's what you're going to use as a Z-score in that case. So if you add one that was closest and no other one was exactly as close, you will just pick that one and run away with it. But in the case where you have two that are equally as close, if this was 0.003 close and this was 0.0005 far, now this one I go pick because now this one close pass. But this one, they are both the same, they have both the same distance. That's why I have to find it this way. So these are cases that are peculiar. It's not everything that will be like this. Some you will know only one will be the closest. But in this case, there was no closest, two were closest. So we have to find the average. All right. So can you see what we have done now? The critical value now for this particular test, where we had the null hypothesis as this, alternative hypothesis as this, confidence level of this, the critical value is 1.645. So that's the way to find critical value of a test. So this is what we're going to dwell on today. And I'm going to be giving you guys questions now. I want you guys to master this so much. I'm not going to bring any more knowledge apart from this. So let's just master this. I'm going to have different questions now being thrown to you. Please make sure you give me your answer as much as possible. Please try and participate so that you can get the best from this class. So of course, you missing it the first time is not an issue at all. Just participate and try and drop your answer. All right. So bring out your Z table. If you don't have it, please try and get it. I believe you guys have printed it already. So get it close to you and let's solve a few questions. Now, let me do something quickly. I'm going to solve this question now for when it was less than. All right. If it was less than, what would have happened? We're not going to have the same answer, guys. All right. If it was less than, this is not the scenario. So let me show you what will happen if it was less than. So if it was less than, look at what will happen. That means I'm going to be having a left tail test in this case. Of course, this is a one tail test, a left tail version of it. So now, this is the critical value here, the Z-score I'm looking for. But don't forget, the confidence level was 0.95. That means my level of significance will be 0.05. And this acceptance region will have an area of 0.95. So now, you have to now find a way to find what Z-score produced an area of 0.05. That's, when we had greater than, this was the test, this was the thing we had to solve. But now, when we're having less than, we cannot be solving the same thing. We have to solve this one right in front of us. So you have to draw out. Now, using a positive Z table may not work here. You know why? Because your positive Z table don't give you values for area below zero, below the midpoint, which was the mean of 0. So you have to bring out your negative Z table in this case. So bring out your negative Z table now. And guys, tell me, what is the area? What's the Z-score that produces an area of 0.05 using your negative Z table? So you have to, again, go and bring out your negative Z table. Of course, it's going to look like this. The only difference is that in that case, you will have it starting from minus 3.4 up until 0.0. That was how your negative Z table is designed. So you have to go on now to look inside this section and ask yourself, what produced the value of 0.05? Looks like somebody wrote the answer right now. So you will go on to check that 0.05. Now, if you look at 0.05 now, you will see that there was no exactly one particular value that was 0.05, just like this case again. There was not one exact value. All right. You will see, I can see from what I have right here, I can see 0.0505. I saw this right there. And I also saw beside it, I saw 0.04. 95, I guess. Yes. Can you see right now? These two, they are also quite very close to each other, because 0.05, this one is 0.0005 far from 0.05. This one is 0.0005 near before it. So you can see they have the same distance away from 0.05, which was what we are looking for. But we could not find exactly 0.05. Please don't go on to just pick that of this. Check, is there any other one that is closer? 0.0505 is true, this is close, but this one also is equally as close. So in this case, if you go on to go and check what produced this, you will see that this was minus 1.6 under 0.04 and minus 1.6 under 0.05. Of course, again, you find the average of this, and then you'll be having this as minus 1.645. So you can see now, this is the critical value if we're dealing with this particular test that has your mu to be less than 4. This is a left tail test now. So for the right tail test, our critical value was 1.645. Anything that falls within this region, if your test statistics, don't forget I told you about test statistics, your test statistics falls inside this place, you will be rejecting the null hypothesis. Now, in this particular case now, if your null hypothesis, if your test statistics falls within this region, that means if you have values that falls in this side, if your values for your test statistics fell inside this place, you will be rejecting the null hypothesis. But if you fell inside all this place, you will not reject the null hypothesis. Why we call this place the critical region or the rejection region, this place as the acceptance region. All right. So let me do the last possibility. Let me do that of a two-tailed test. So let's assume we don't, this I've done for, right, for less than, I've done for greater than, let's do for not equals to. All right. Now, in this case, we'll be dealing with these two scenarios. You know that already. We'll be dealing with both the left and the right tail, because we don't, not equals to can be less than, it can be greater than, it shall not equals to, that's what matters. So it could be less than, it could be greater than. Now, how do we get the Z score for this? Follow the same process. First of all, I told you the area for the rejection region is, in this case now, the area for the rejection region is always alpha. But here, when we have two different rejection regions, to be alpha over 2, this will be 0.05 over 2, 0.05 over 2, and that will be 0.025. All right. So that means in this case now, the area here is 0.025. So if this is 0.025, of course, you can see 0.05 divided by 2 is 0.025. 0.025. So the same way, if I want to find the Z score, you know, you have to find two Z scores now. You have to find the Z score, this for this place, and you have to find for this place. Now, I would have given you something and hint. I'll give you the hint after I'm done doing it the manual way. Then I'll give you a hint that always happens. You will even notice it yourself, by the way. Now, you go into your looker to find this place. You already know how to use your normal distribution table. Your standard normal distribution table. You cannot, you find this place, you go to your negative, because this is below 0. So you'll be using your negative Z table. Go and find the area of 0.025. The area of 0.025. What does it give you? What's Z score? So again, you go within this place again. You go and look for the area (0.025). You start looking for it, 0.025. So that's the work. The major work you will do majorly in this kind of question is checking your table properly. So I can see 0.0. Okay, anybody seeing it there? Okay, I can see an exact value of 0.025 on 1.9. Can you see that? 1.9 minus 1.9 under what? 0.06. Check that. To see the exact value, you check your negative table now for 0.025. There's an exact value of 0.025. If you want to get that, go and check minus 1.9 under 0.06. Guys, confirm that you will get an exact value of 0.025. Can you guys see that? No, what you guys are saying is not correct. There's no 0.5058, not at all. Not at all. That's not it at all. I'm asking, we're trying to find, this is the area 0.025. 0.025. You go to your table, you find the area, you want to find the z-score that produces 0.025. All right. So if you go on to check minus 1.9 under 0.06, you will see exactly 0.025. Sometimes it comes that way and you see the exact value. Sometimes it doesn't come that way, as we have seen in the previous example, where you have to pick the ones that are closer. So under this one, you can see minus 1.96 produced that z-score. All right. Now let's try and find for the other z-score. Now I'm going to tell you this: if you have a question like this, I'm very sure this place will be 1.96, but I'm going to solve it. When you have a question like this, it's always going to give you the same. This will be the negative value, this will be the positive value. But just for the sake of people that will say, how are you sure that's going to be the case? Let's try and find the z-score using our area also. So I told you guys already that the area for the acceptance region is what? 0 point is the confidence level, right? The confidence level is always the area of the acceptance region. This is the acceptance region I'm pointing to right here. Our confidence level is 0.95. So that means this area is what? 0.95. Good. So what's the now to find this place? Of course, you know that if you want to find the z-score of this place, you will have to say you are finding the area for the whole place. The z-score here will produce the area for left to the right till that place where the z-score was. So from the left to the exact point where the z-score was, that whole area is what you'll be considering. So that means the whole area from here up till this point will be 0.95 plus 0.025. I'm sure you guys understand that. Thank you very much. So that means the area you are looking for to find this particular z-score will be the area of 0.975. Of course, how you got this is that 0.95 plus 0.025. All right. So 0.95 plus 0.025. So that will be 0.975. Now, you're dealing with an area after the midpoint. So you'll be using your positive z-score in this case. Your positive z table in this case, not your negative. When it's below the midpoint, you bring out when you're finding area below the midpoint or you are trying to find z-score below the midpoint, you'll be making use of your negative z table. When it's above the midpoint, you'll be using your positive z table. So bring out your positive z table now and check for the area of 0.975 and confirm what values of the z-score produce 0.975. 0.975. So 0.975, I'm sure you're going to see it under 1.9 under 0.06. You can confirm that. So if you bring out your positive z table, 0.975 will be 1.9 under 0.06. This is what will bring out 0.975. So that means obviously this is going to be 1.96. As I told you already, it works that way. Once you have a scenario like this where you're dealing with a two-tailed test, if this was minus 1.96, this place will be 1.96. I'm just telling you guys so that in case you need to save time, you don't need to go on finding both of them, except if they are not the same thing. That means it's not equal, which if it's not equal area, but since you are saying you are cutting out an area of 0.025 here, you're cutting out an area of 0.025 here, of course, you are taking out the same portion. So whatever you get here, it's just going to be the mirror of it, of course, in the positive section now. So just understand that, and that's how you find the z-score. So guys, I want to give you guys the things you now do on your own. Like right now, I'm going to give you some time to solve it so that you can get this very, very strongly. So let me just do a quick tweaking here. What I'm going to be doing majorly is changing this to 0.99. So the confidence level now is 0.99. Guys, I want you to find for when the null hypothesis, sorry, the alternative hypothesis was greater than. I want you to find for when it was less than. I want you to find for when it was not equals to. So you go on to produce each of the critical value for those three different scenarios. That's what I want you guys to do now in the next few minutes. So you go on now to find the critical value. Of course, don't forget your C now. Your confidence level is 0.99. And it's still the same question, but now you're dealing with greater than first. Do for greater than. Tell me what your critical value was. Do for less than. And do for not equals to. That's what I want you to do quickly. So you start from greater than. Greater than, tell me what your critical value is. So this is time to work. So this is where we're going to emphasize on, so that once you are done with this, I assure you guys, you are done with Z testing. Like the rest is something everybody can do. This is just so vital. That's why I want you guys to get very perfect with it. So the first thing I said you should do is for when your mu is greater than, when your alternative hypothesis is greater than 4. That's the first one. Do for greater than first. Tell me what your critical value is in that case. At this point, I expect you guys to be checking your table. This is how you get better at this thing, by practicing. All right? You have to practice to make perfect. So for the very first question now, we're dealing with this, obviously. And of course, this is a right tail test. So we're going to be having a scenario like this. So we want to find the Z score for this, which is obviously going to be the critical value. Z score in this case is the critical value. So my confidence level is 0.99. I told you that the area of the acceptance region is 0.99. Obviously, the area of the rejection region in this case will be 0.01. All right. So what you have to do right here is go on now to your positive Z table now and go on to look for the area 0.99. Ask yourself what was the corresponding Z score in that case. So 0.99. So what's the value you got, guys? All right. If you check your table, you would see that, of course, you're using your positive Z table here. You will see that we go on to check, I believe, 2.3 under 0.03. 2.3 under 0.03, we produce 0.9901, which is the closest. Now we have a value of 0.9898, but if we check this out, you see that this is 0.0002 further. 0.002 further. This one is 0.0001 further. So, sorry, this one is 0.0002 closer, whereas this one is 0.0001 further. Obviously, this is the one closest to 0.99. So I'm going to be using 2.33 as my Z value. All right, so that's the Z score for this case. So this is my critical value for this scenario. So go on now to find for the one of less than. So less than, we have of course, it's going to be like this. I'm sure you agree with that. And in this case, now we're dealing with, of course, this is the rejection region. So this is going to be the area of 0.01, whereas this is going to be 0.99. All right. So this is going to be 0.99. You want to go on now to find the Z score. So you're going to be bringing out your negative Z table. And you're going to be looking for what produced 0.01. If you go to your negative Z table now, you have to go on to look for 0.01 under in your negative Z table. 0.01, you go on under minus 2.3, under 0.03. Yeah, so you're going to see these values. So if you check minus 2.3 under your negative Z table under 0.03, you would see a value of 0.0099. 0.0099. Now, this is closer to 0.01 than the other one close by that was 0.0102. We have 0.0102. This is close, but not as close as this. So we're going to be using minus 2.3. So that's going to be our Z value in that case. All right. And the last value is when I told you to solve for not equals to. Not equals to. So you have a scenario like this. This is a two-tailed test now. Now, in this case, your alpha is going to be your rejection region, but in this case, you're going to be having 0.01 divided by 2, 0.01 divided by 2. Whereas this place is going to be acceptance region, this is going to be 0.99. All right. So you see what we have right here, 0.01 divided by 2. So right here we have the value of 0.005. Of course, this is also going to be 0.005. I'm sure you guys understand that all these are still very much intact, because if you add all these things together, you must give you a value of 1. So what you want to do right now is to go on now to find 0.005, the area, and ask yourself what Z score produced this area of 0.005. So you have to be looking at your negative